Okay, we're back. This is Techmath1. We're looking at the notes for chapter 2. We're on section 2.3. And we're going to start with number 32 on page 64. So we're solving two-step equations now. Two-step equations. So we have to isolate the variable, get the y all by itself. So we subtract 28 from both sides. And what that does is now we get 7y plus 0, or just plain old 7y, is equal to negative 28. And so it's isolated. That fancy, we got it by itself. Y is all by itself. But we want 1y equals, not 7y. And so the idea is isolate the variable, make sure the coefficient is 1, and then you have solved the equation. It's an equation because it has an equals to sign. And so we would now divide both sides by 7, and y would equal negative 4. All right, same dog, different fleas, minus 2 from both sides. We got negative y is equal to 6, but I don't want negative y. Remember, it's a negative 1y. I want just 1y, so we divide both sides by negative 1, or if you'd like, multiply both sides by negative 1, it doesn't matter. You will get negative 6 either way. And let's jump to 39. Isolate the variable. We get negative 1/6 x is equal to negative 1. But I don't want negative 1/6 x. I want to get the coefficient to be 1. So that means multiply by the reciprocal of this fraction, which is negative 6/1. And a negative times a negative is a positive. That's positive 6/6, which is just 1x. And a negative times a negative is a positive 6/1. So just 6. The good thing about all of these is you can check your answers. You pop negative 4 back in. 7 times negative 4 is negative 28, plus 28 is 0. You pop negative 6 back in. 2 minus a negative is actually a plus, so 2 plus 6 is 8. You pop 6 back in. 1/6 times 6 is 1. 1 minus 1 is 0. So you can always double check your answers. That was 2.3. Let's take a look at 2.4. That's going to be the distributive property. Okay, so 2.4 is the distributive property. So we're looking at in the blue book, we're looking at page 68. So that's number 40. So we got 6 times 3x plus 7. And we've got 5 times 10 plus y. And so they want us to do the distributive property. So that is, if you look at this number out front of the parentheses with nothing in between, which means multiply. So what I'm going to do is I'm going to take 6 times 3x and 6 times 7. So 6 times 3x plus 6 times 7. And then what does that equal? Well, that's going to be 18x plus 42. And that's it. These are expressions. It isn't equals a number. It was just, this was the original problem given. It's just they put a couple of equal signs in there. Normally, I wouldn't do it that way. That's just how the book kind of set it up, as equals and equals. Because whenever you're doing expressions, there's no equals to sign. Whenever you're doing equations, there's an equals to sign, like equals 7 or equals a number, okay? But I think just for sake of going this way instead of coming down, that's why they put those equals to signs in there. Really, it should be like this, where you go, okay, 5 times 10 plus 5 times y is 50 plus 5y. That's usually, like in algebra, this is a very strict rule that when you have an expression, you don't see an equals to sign anywhere. So you just simplify the expression. And that is as good as it gets. Same as that. That is as good as it gets. There's not an equal sign. We're not solving equations like on section 2.3. It's we're just simplifying expressions now. All right. So like I said, I think the book just did it to save room. So they have like 2 times x plus 7 on number 42. But then they have equals what, and 7 times 5b plus 1 equals what, and 5 times 6 plus y equals, and 8 times 5 plus 7m equals. And so it's just to save room, I think, that they busted out the equals to sign. But 2x plus 14, 35 plus 7, 35b, oops, don't forget the variable. 35b plus 7, 30 plus 5y, and 40 plus 56m. All right? So we can't do anything with those. Don't make it into an equation where you say equals 0 and move the 14 and divide by 2 or something like that. That does happen a lot in math because it looks similar to what we did before. But so make sure not to do that. And then I also wanted to take a look at 45. One more here, 2.4. All right, so 45 is a is negative 3 times y plus 7. And b is negative 5 times 2d plus 1. And c is negative 1 times m minus 9. And d is negative 10 times 4 minus 2d. And so we do the distributive property. That is negative 3y minus 21 or plus negative 21. It doesn't matter. Those are synonyms. Either you can just leave it minus 21 or plus negative 21, whichever you want. So look, this one I'll do it differently. We'll do negative 10d, and then we'll say plus negative 5, because negative 5 times 1 is negative 5. This one, I just did it. Now, normally in math, we're the laziest possible people we can be, and so we don't write plus and negative. Usually we'll just use the minus because it's one less symbol to write. But either one of those are fine. In the same vein, we don't put the 1 there. There is a 1 there. Whenever there's nothing in front of the variable, there's a 1. But we rarely write the 1 down. We usually just say, okay, negative 1 times m, that's negative m. I don't usually put a 1 there. You can. It's not wrong if you do, but you don't have to. Okay. Lovely, lovely. All right, so let's see how much time we have on that video. Oh, that's only 8 minutes. Here, we'll do another section. Let's do 2.5. Where we got number 47. That is, what do they want us to do here? 7y plus negative 5y equals, let's see, I wanted you to do 47. What are we doing here? Just combining like terms, I guess. Oh, they're having us explain why you combine like terms. So look, the 7y plus negative 5y, those are like terms. So we put them together, and that's just like 2y. But they actually want a brief explanation. Why do we do that? Why do we just change the numbers in front when we're combining like terms? This is why. Because you could factor out a y. I could think of this as y factored out, 7 plus negative 5. You know, if I pull that out, and then that would be 2, and that would be times y, and then I'd write it 2i. Now don't do this. This is all a bunch of extra work. This is just the explanation for why, when you combine like terms, you only change the coefficients. You only change the numbers in front. All right? And really, it can't be explained well until you understand the distributive property and then factoring, like factoring out. All right, so like 50, x plus 3x, and m plus m, oh, m and m's, 10d minus d, and v minus 4v. So let's take a look at these. That's 1x plus 3x is 4x. That is 1m plus 1m is 2m. That is 10d minus 1d, that's 9d. And that is 1v minus 4v, that's negative 3v. And so, even though we never write them there, they're always there. There's a 1 all over the place there. Those are all 1s. And so sometimes I've had students actually write them down before combining like terms so that they remember that it's a 1, because your brain usually when you look at things like that just registers it as nothing's there. And so a bunch of people get that wrong because they think it's 0 plus 3 is 3. It's 1 plus 3 is 4. So be careful about that one. All right, let's jump to 58. That's all decimally. 6.8y minus 2.4y is equal to negative 88. So we're going to solve this equation. It's an equation now. It's equal to a number. And so let's combine like terms. That's not officially solving yet. When you're combining like terms, you're just getting it cleaned up. It's like you're going to go out on a big date, so you take your car and you go get it cleaned up and vacuum it out and everything. You didn't really start the date yet. You're just getting the car ready and you got all, showered, dressed up and nice. You're preparing for the date, all right? So same deal here. This isn't actually solving the equation yet. We're just getting it cleaned up so it's ready to be solved. So 4.6 y is equal to negative 88, right? Because that's a positive 6.8 and negative 2.4. So 4.6, yeah. And now we can start solving the equation. After we combine like terms on both sides, there's nothing to fix on that side, just on the left side. Then we solve the equation. So we got this. I don't want 4.6, I want 1. So I divide by 4.6 both sides. And we end up with y is equal to, I think that goes evenly. Y is equal to, where was I here? Negative 20? Is that negative 20? 88. I think so. Yeah, negative 20. No, that can't be negative 20. 4.6, 2.8, 6.8. Oh, that's because that's 4.4. Sorry about that. I don't know where I got a 6.8 minus 0.4 is 0.4. You're probably yelling at the screen, right? 4.4, 4.4, 4.4. There it is. That's 20. So 6.8 minus 2.4 is 4.4y, and then we divide both sides by 4.4. I was too worried about explaining combining like terms to focus on the actual numbers. Sorry about that. All right. So here, let's do 61. That's where I kind of miss having you guys here in real time, like face-to-face classrooms, because you can catch little stupid errors like that while we're following along. All right, so this is just combining like terms. So we're back to, these aren't equations again. It's flip back to expressions. We're just combining the like terms. So we can't put the 7x with anything, but 7x would stay, but 10 and 5 is 15. We can't put the 9 with anything, but the y's we can put together, 1y, 3y is 4y plus 9. Again, the y's we can put together, negative 4y plus 4. And again, the t is standalone, negative t, but then we got 5 and negative 4 is plus 1. All right, so order doesn't really matter which way you write it. If you look at the answers in the book, they wrote 15 plus 7x. They wrote 4y plus 9, negative 4y plus 4. But then they wrote 1 minus t, and I did negative t plus 1. So it really doesn't matter when you're combining like terms. I usually put the variable first, just as a, you know, normal kind of thing to do. And then let's do 64, that's 2.5. And that's going to be, solving an equation. So we're back to solving an equation now, but they have us having to combine like terms first. So combine the like terms, negative 2y plus 10. And now all we did there was we cleaned up the right side of the equation here. So now let's isolate the variable. So negative 1 equals to negative 2y, and then divide by the number in front of the variable. So positive 1/2. Again, if we have context to the problem, if they told us, oh, that was money, I probably wouldn't say 1/2, I'd say 0.5, like 50 cents. But without context, just leave it whatever you have as like a fraction. All right, the last video for chapter 2 will be 2.6 to 2.9.